Hi everybody, it's Kevin here again. It's been a moment since I've done a tutorial. I've taken some time off to work on a few personal projects and things like that, though I'm glad to get back in the groove of things. I wanted to get back into it with some cloners and HUD graphics. I've had a few people ask me about that, and I think the key to it is really understanding how to use cloners and using that to make some really awesome things. So let's get started and make a HUD graphic like this. Click accept and let's jump into it. So we'll start with a blank node graph here. We'll go ahead and start creating our first cloner system. So the base of every cloner system is this sort of cloner root. There's a few other different types depending on the look you're trying to get. You can clone to a volume or clone to particles, things like that. We're just going to use a basic cloner. If you use C4D, things like that, it's very similar to the cloner that's built in there. You need some type of geometry to clone, so we're going to start with a basic primitive shape. I try to stay within the Notch ecosystem as much as I can, just to keep things simple and make it easy. So right now we've got a sphere. I'll turn on this grid just so we can kind of visualize where we are in 3D space. What we're going to start with doing is let's make a ring of bars basically that sort of push outwards in random patterns, and it almost looks like a voice FFT style thing. So to break that down, we could probably construct that out of a ring of what I would think of as boxes. So instead of a sphere, I'm going to go ahead and change this to a box. And we kind of want them long and skinny, right? So I'm going to decrease my X amount here and decrease my Y. And we kind of have this long skinny box already. To make a ring in your cloner, you can change your iterative cloning mode into a sort of radial mode. And what it does is you'll see it turns them into a sort of circular pattern. And since I have 5 clones set right now, you'll see we have 5 clones. If you want to change the plane that it's cloning in, right now it's kind of in the YX plane. I'd rather have it in the XZ plane, and you can select that right down here under radial plane. So if I change it to XZ, you'll see we kind of already start to get this star style shape. And let's increase our number of cloners a little bit. I'm going to jump to say like 90 of them. So we get this nice spiral. If you want to do HUD graphics, one key thing is kind of nice fine line work. So I'm going to decrease the width and height of these cubes a little bit more. So let's go even finer. In fact, I'll type in a number here. Let's do like 0.001. So that's really nice and thin. And we might want to make that a little thicker later, but let's work with that for now. I'm going to turn off my grid. So one thing that will help from keeping your lines getting too jagged is make sure you have anti-aliasing on in your root node. That's typically something I'll pretty much always turn on by default. So right now they go all the way to the center. I kind of want them to end at some radius outside of here. So let's decrease the size Z on this a little bit. And you'll see it's already starting to look like a ring of bars. You could turn this into a speedometer really easily, things like that. You know, let your imagination go wild. I'm going to turn up the number of clones a bit more. Let's double it. Great. So we've got this kind of fine grid. You can see this is a really simple node graph right now, just literally cloning a box around a circle. Another key thing with cloners that I find is a really, really great animation and visual tool is effectors. So there's a few different effectors in here. One of my favorites is probably this Turbulence effector because you can do some type of animation with it. So if I feed this into the input of our cloner, nothing happens yet because the default is that everything's set to 0 in our effector transform. So if I twiddle some of these values, you'll start to see something happen. So you'll notice there, position Z starts to move these bars in and out. Position Y moves them up and down in space. You can make some really cool patterns. I think I'm going to go for is this sort of scale Z parameter here. And you'll see it kind of varies the length of these bars that we've created. I might make them a little shorter here to begin with, and then you can crank this value up further depending on, you know, how extreme you want this variation to be. So if I hit play right now, you'll notice by default the Turbulence effector will actually animate. And it uses these settings up here in your attributes. You'll notice there's an animation rate which dictates how fast it changes. So if I slow that down a little bit, you'll notice it animates much slower, and I like that a lot more. I think I went a little too extreme with the scale Z, so let's turn that back a little bit. You'll notice right now, because it's scaling along the length of this bar, they stay centered on this axis. Kind of looks like a voice command. But in this scenario, I want the center to look like a clean circle and the outside, like these bars, to kind of grow outwards from a clean center. And the reason that that's not happening right now is our shape. If I plug this into the root and look at just the shape, you'll notice it's centered at 0, 0. So when you scale it on Z, it scales in both the positive and the negative direction. So if you want to change that, I think the easiest way to do that is to put this shape 3D in a null. So let's add a null. And I'm going to put that in between our cloner and our shape. So nothing has changed. Our null is centered at 0, 0, and our shape is also at 0, 0. But you'll notice as I start to move our position Z on this shape, it's cloning the offset of the shape within the null. So your cloner is treating these two nodes together as if it was one object. So this is a really great way to affect some type of control over how you clone an object beyond just the size of the object or things like that. So right now, since our box is 0.1 in size Z, if I offset it by 0.1, you'll notice it leaves us with this perfectly clean circle interior, which is kind of what I was going for. So that's great. I'm going to turn on this scale Z a little bit more. And then we can play with our noise scale here. A smaller number for this means your noise is more gradual as you move along this curve. And if you make this greater than 1, say 2, you'll notice we get a bit more variation in this, which I kind of like. I'm going to split the difference there and find something in the middle. So right there, I think that's pretty awesome. We've got this sort of bar, like bar visualizer look. It's a little plain, so let's add some more detail. And this is kind of where you can get into creating complexity by layering a few different cloners. So we've cloned bars in this circle. You'll notice it jumped right there. That's because my playhead, if I hop to the end and move back 5 seconds, if I play it, when it loops, our turbulence effector right now, the animation is looping. If you don't want that to happen, just go into your turbulence effector and change the update time mode from lock to timecode to running/loopable. And if I jump to the end again and play through, you'll notice this time it won't jump when your playhead resets. So that's a good little tip. Just be conscious of that if you want this noise to look the same every time you play it versus if you want it to loop and you're going to use this as like VJ input or something like that. So let's add other elements to this. Let's create another cloner. So if I add another cloner, this time let's add some rings that kind of move in space up and down and give it a sort of like scanning look. I'll just duplicate our shape 3D from here. And this time we're going to make it, let's do a torus. The reason that I like doing 3D objects instead of rings is I find, or like flat items like rings or circles, like for instance, the boxes that we use, we could have made that instead with lines, which might seem more intuitive. But the reason I like using 3D objects when I can is that you can actually material them and you can do proper lighting and depth of field and things like that. So I always choose 3D objects when I have the option. If you absolutely can't do it with a 3D object, then obviously that's a different scenario. So let's take our torus and I'm going to lower my inner radius here so that it's nice and thin. Let's kind of match the value that we had in our box earlier, which is 0.001, really nice and thin. Maybe 0.002. And you'll notice we have some of these segments here. It's because we only have 20 subdivisions in the X, which is kind of going around this ring. So I'm going to change that to 100 and make it really nice and smooth. We probably don't need 20 subdivisions in the Y, which is this radius that goes around the torus. So I'm going to lower that to like 4 and you don't see a difference at all. So there's our ring, right? I've accidentally offset it in, or the position Z got copied over. So I'm going to reset that. And now it lines up with the inner of that perfectly. And let's go ahead and clone this. This time we're going to use 3D grid. You'll notice the default is that it makes a 3x3x3 grid. I don't need any clones in the X or the Z, so I'm gonna make those 1. I think 0 does the same thing, so you can also make a 0. But let's make 5 clones in the Y. And you'll notice right now that it's kind of far apart. Our grid size Y is quite large, so if we lower that a bit, now they condense in a little closer. And that's kind of a cool look right there. You can have a series of rings that circle some object you're looking at. Let's take the same turbulence effector and use that to animate this, but instead of scale this time, let's look at doing a sort of position Y animation. So if I at 0.5, you'll notice these circles now kind of slowly scan up and down. It almost feels a little random, right? Which is exactly what I wanted. That's good. I want a little variation in the size of these, so I'll look into a randomize effector, and I'll feed that in as well. And this randomize effector now, we can, if we check uniform scale, we can use this scale to control scale in all axes. Without that, if you only adjust one, you'll notice they become ovals. So I kind of want them to scale uniformly. And if I want them to get smaller rather than larger, you can just do a subtract symbol. And there you go. We have a little bit of variation now in the size, as well as having them animate up and down in the Y. And let's say I want some variation in the scale as well in terms of animation. So the randomize effector doesn't have an animation parameter. It's kind of a fixed setting. So if we add another turbulence effector, we could change the scale of these items rather than the position and have that animate as well. So if I make uniform scale here, and let's say we make it 0.4, let's say, you notice now they kind of slowly scale in and out as well. I want them to scale much slower than how fast they move up and down. So I'm going to lower this animation rate to something really low. And so that's kind of cool there, right? They look like they're kind of scanning any item that you put in here, or at least reacting to it. Let's say I want to add some color and have these circles here vary a little bit in terms of color. I don't want them to all be white. Variation is good. I think it gives it detail. And for that, there's a great effector called the color ramp effector. And if I connect that here, you'll notice that nothing happens at first. It's very much like attribute shading in particles in that it needs a color ramp input. Can't spell. Color ramp. And I'll feed that into this color ramp input. Let's do like a dark blue-ish to white. And so I have blue and white selected there. In our color ramp, it kind of turned everything blue. That's because it's set to a source channel of position X. So we could change that from position X to say fractal noise. And notice now it kind of animates through that. The color ramp effector is a technique that I use all the time to animate color of objects. So instead of it animating so quickly, it's just like the turbulence effector. We can lower this animation rate. And if we want some more variance between neighboring circles, we can increase this noise scale to say 4. Now let's do like 2. We can also increase this gain. You think of it like noise, it makes the noise, if you visualize the noise, it makes it look more contrasted. So there will be a greater difference between neighboring tones. Let's lower that animation rate some more. And let's also change this from lock to timecode to running loopable. Then it won't jump when your notch layer loops again. So that's kind of cool. We have these sort of glowing, moving rings, and you'll notice that everything looks quite flat right now. I think a really essential piece of HUD graphics is a little bit of glow, a little bit of the feeling that each of these elements is emitting its own light source. So we can add a little bit of glow just to help us start to visualize what this cloner system will start to look like. And right away when you add a glow, you'll notice it's probably a little bright, but it starts to feel much more HUD graphics like. I'm going to raise this threshold a little bit. And great. So there we go. We have some ring elements. We have these bars that we made earlier. Let's add next some more sort of discrete geometric things. I think I had some triangles going. And it's kind of a fun thing. I think it's always a good challenge to see how much you can make a notch before you jump into another program. Every time you can make something a notch instead of another program, it's going to save you some time. And your whole scene is going to be more procedural, so it's easier to go back and edit it without having to open up other programs or things like that. So if we make a copy of our radial bar system here, I'm just going to duplicate this whole system here using Control D. And I connect it back to my root. You'll notice I made a duplicate of all the bars. So let's lower the number of clones to 4. And let's also decrease the radius here, how far they are from center. So that's kind of cool on its own. It's like a crosshair system, but let's try and make you know, a larger shape that takes up more space. So I'm going to go back to a torus, and this is a really fun trick that I like using all the time. Is if you think about what a triangle is, right? It's really just a ring with 3 sides. So if we lower our subdivisions x here to 3, you'll notice we just instantly made triangles. Similarly, if you made it 4, you would make a square, right? So this is a tactic I really like to use to make simple shapes in Notch, is just take a torus and lower your subdivisions. Similarly, we probably don't need 20 subdivisions around the radius of each of these bars. And if we lower this inner radius some more, you'll notice they immediately start to look more like HUD graphics elements. So they're a little rotated. I kind of want the arrow to point in. We can first zero out this position Z, and we can also just rotate this heading so that the arrows now point in. Because they're triangles, the correct amount is -30 degrees. So there we go. We have a ring of triangles that feel like they're pointing you visually into the center. It's almost like a crosshair system. I'm going to widen, or I'm going to enlarge the triangles a little bit, and in the cloner, push them outwards just a tiny bit so that they almost sit near this inner ring here. In fact, we could even go for some overlap and it might look quite nice. There you go. I like the way that that looks. So if I'm gonna make this edge of it a little bit thinner so it just looks more refined. And in terms of layering complexity, like we were talking about earlier, one way to make this complex is let's add some more detail to this triangle itself. If I make a duplicate of this torus here and I layer it into the same cloner, I can make a second triangle that sits within that one, and boom, there's some complexity right there. If I want that middle triangle to be more filled in, for instance, you could either increase this inner radius, or you could also make it a cylinder, right? A cylinder is essentially a filled in triangle, you could say. There you go, that looks pretty nice. I'm gonna lower my glow slightly, it's a little bright. And let's give this shape a material. In fact, let's give everything a material. Let's start defining some of that. Like your color ramp effector back here will actually respect the material that you feed into this shape. So if I feed something like this in, it's not going to have much effect because it already has a color. If we do it to these triangles, we can define a color for these triangles. So we might pick something that's kind of in this blue spectrum, right? That's a nice hue right there. And then suddenly our glow looks a little better because they're no longer saturated or desaturated, so they glow a little bit less. So there we go. We have some triangles. I kind of want a really large ring to outline these bars here and give it some really defined form. I'm going to make a copy of our torus here. And this one I'm not going to clone because I only want one. I'm just going to connect it to our root. We'll make it 100 subdivisions in the X. And let's increase this radius until it matches these bars, which is conveniently a radius of 1. So we'll leave it there. So let's increase this inner radius a tiny bit. And actually, let's bring it a little, I want a little gap, there you go, between the ring and those bars. And we'll copy material and also material this torus so that it sets it apart from the rest of the scene. I'm going to choose to make this one a slightly lighter blue to give it a little bit of emphasis, you could say. So I'm going to go ahead and save there and continue. So we have some cool elements here. I think one way to add some really nice flare is to add some particles. I might do that a little bit later. Let's add let's go into how far you can layer cloners and make a really complex central thing here like we had in the intro. And how I made that was I layered 2 different cloner systems in. So if we make a copy of, let's make a copy of these bars again. You can say I like to reuse whenever I can, saves you some time. We will, let's decrease the radius of this cloner here. Oops, wrong parameter. All right, so it's in between here. And let's remove this box shape and turn it into little dots, so like spheres, right? So that's massive 0.001. There you go. So we have a bunch of small, tiny spheres here. That might be a little too small. There we go. So one fun thing about radial cloners you can do is you can change your radial start and end angle. So if I change my end angle here, you can see it. You could animate this, for instance, but you could also just define how, like parts of a circle to get circular patterns without filling out just plain circles. This helps us break up the form a little bit. So you can see I've got a row of circles here. I probably don't need 180 clones. Let's lower that a little bit. And let's do a radial end angle of, say, I don't know, 90 degrees. So it's 1/4 of a circle. I'm also going to turn off this turbulence effector for now. So how do we add complexity to this? One thing I really enjoy doing is cloning cloners. So you can layer cloners into more cloners to clone those again and make even more intricate patterns. So what do I mean by that? Let's duplicate this cloner that we have going here. And let's clone the cloner that we already had. And you'll see right there, it's basically made a bunch of copies of that ring of the quarter ring of dots that we just had. And in this parent cloner, I'm gonna make this radial end angle such that it fills our whole circle. And right there, you can see we're already getting a really cool pattern. And you can play with this a lot in terms of, we can orient our child cloner within our parent cloner and get all sorts of patterns as we rotate this bank, for instance. And I kind of like the way that that looks. So if I rotate our bank, you can see it's kind of stemming from our 0y upwards. I can make this radial start angle be -90, so that it makes this mirrored pattern from -90 to 90. And I might decrease that range overall, so it goes, say, -60 to 60. And we can start fiddling a lot now with things like the number of clones in our parent cloner to get much more intricate patterns like that. We can also change things like the radius of our child cloner to make that a little larger. And we can also change the radius of our parent cloner so that it brings it in closer to the middle, for instance. So that's kind of a really cool look there. I might increase our number of clones. And as you do that, you can see this pattern starts to change as well. And let's increase that radius slightly like that. And so let's give it a little variance with this turbulence effector that we had going earlier. I think right now this is it's adding to our scale by 2. I'm going to make it uniform, and I'm going to make scale x1 and change the scale apply mode from add to multiply. And what that's going to do is it's going to take some value between 0 and 1 and multiply each clone sphere by that for the scale, and it's using our fractal noise right now to drive that. So if we now change our noise scale, we can get different patterns out of this basically. That might increase our gain a little bit. So there you kind of get this cool fractal noise scanning pattern. I might decrease our noise scale to get sort of larger effects. And so that's kind of a cool look there. I'm going to increase our scale X even more. That might be a little too much. Let's do 3. So now you get some cool patterns that kind of wipe along this thing. You can also play with your gain to see how much that affects in terms of the texture contrast. And that can have quite a drastic effect there. I'm going to lower our noise scale even more. So it's kind of this really large wiping effect, which is really cool there. So that's a really nice, nice complex visual that's made from cloning a cloner that all started with one sphere. So you can see here how complicated this can get. You could clone your cloner system and do as many layers of cloners as you want. And you can see here on the performance, it has actually it's very performant because they're iterative copies of an original clone. So instead of literally having, 60 times 50, 3,000 objects there, you just have 3,000 instances of a single object, and it makes your system process this much faster than it would if you were to make these objects individually. So that's the nature of making complexity with cloners and having it be really, really performance oriented. So if you're doing real time, this is a great way to add HUD graphics or complexity to any of your scenes. Let's see. Let's give this a little bit of color. I'm going to copy this material and feed it in as well. And I'm going to make this blue a little bit darker there. And that's nice. I might even increase our number of clones here to give it even more complexity here. I don't think I need to make them quite as large with our effector, so there's a little smaller. And I'm going to increase our range of start angle and end angle so it's spaced out a little bit more. I almost don't like how much they're disappearing. I think I'm going to change this back from multiply to add. And I'm gonna just decrease the initial size of our spheres so that they're not quite 0, but just a little bit larger than 0. And I kind of like that a lot more. I'm gonna increase our noise scale slightly. There you go. So that's a really fun effect. I mean, again, make sure that you play with all these settings. For instance, you could give it a little bit of displacement, which changes how it looks entirely, right? You can also change rotation. So these spheres, you can't see rotation, but there are boxes you could have them twirl about. You know, pay attention when you use effectors that there's a fall off. By default, the fall off is sphere. If you don't want this effect to fall off as you get further from the location of the effector, you can change this to infinite. And that means that it'll have an effect no matter where you are in this scene. Whereas if it was set to sphere and this effector was far away, it wouldn't have any effect here because the effect would have fallen off by then. I might actually increase the speed of this animation slightly. There we go. So this is pretty close to what I was showing you guys earlier. All that's missing now is some particle flare, so we can go ahead and add some of that. I think it goes a long way in terms of adding some almost like dust detail to your scene. So particle root, let's add an emitter. Let's do, I think I did a mesh emitter. So we can emit particles from some of these mesh items that we created, like this blue torus, for instance, I think is a perfect candidate. So if I feed it into our mesh emitter and add a little point renderer here. So right now it's kind of just spawning on the vertice there and it's not moving, so it looks like bands on this. We can change our mesh emitter from vertices to polygons and they'll emit more along the surface of it on every polygon rather than just the mesh vertice points. And if we give it a little bit of an effect, I'm going to do a force effector that slowly pulls it into the middle. Oh, I got a little crazy there. Do a tract, and we'll make this a really small value, like 0.1. So you can see it's pulling these particles in. The particles are huge, so I'm going to make them much, or not alpha, just much smaller. There you go. So we go for like 0.1 there. And there's a lot of particles. I don't want nearly that many. So I'm going to cut down this 30,000 to say 3,000 particles, and that should be great. And also decrease the life a bit so they don't actually reach the center there. Let's see how that looks. There you go. We kind of have this cool suction effect that's going on. Make these particles a little bit larger and give them a little bit of size randomness here. So it looks a little more varied. And then let's also add some line connections. That's probably one of my favorite things for doing HUD graphics, is doing some techie digital line connections. And that's way too much there. Let's decrease the number of connections per particle and also decrease this distance threshold. And you get this really nice light line connection effect as these are pulled in. And I think that's a really Portal-like look there, which is, I really like that. Let's also add some kind of floating particles in space here that aren't affected or pulled in. They're just kind of atmospheric. So we're going to make a separate, just a primitive emitter system. Because we have two emitter systems now and one particle root. Well, I also need to lock this fixed update rate. Totally forgot about that. You can see that it's rendering both. I might want a different render style for these atmospheric particles so that they kind of make longer connections and hang around. So I'm going to just go ahead and wire up my scene using the rendered emitters inputs as well as the affected emitters. And we go over this a lot more in the particle complexity tutorial. If you've watched that, then you'll know exactly what I'm getting up to here. So let's also render these points in this primitive. You can see they're no longer affected by the force effector since it's not an affected emitter. And I'm going to feed this into this rendered emitter as well. I don't want nearly that many. Let's do like 300, just a touch. And for this, a primitive emitter, I don't want it to be a perfect sphere. I kind of want it to be a little wider than it is tall. Something like that, I think is perfect. Maybe a little taller in the Y. There we go. And now when the particles emit, they're going to be this sort of surrounding atmospheric touch. I'm going to turn off repeating random and uniform distribution so that they are a little more randomized as this thing plays. And we're going to make them live quite a bit longer. Let's do like 20 than the other particles since they're like kind of dust specks that are floating around. Let's also change, or let's also add a line connection renderer here. One thing I really don't like about primitive emitters that are spheres is that they emit more in the center than towards the outside. And that's probably because I turned off uniform emission. One way I get around that is by checking emit on surface. And if you do just that, they only emit on this outer surface. But if you want to offset them, I use this random offset parameter to basically define the surface where they're emitted from, but then offset from that slightly. So I get a much more even distribution here that's not so focused in the center, but it's kind of focused around where the surface of this emitter was. So I might make that slightly smaller here. And let's restart and take a look. That looks quite nice. So let's add some line connections. These I want to be much longer. So I'm going to increase this distance threshold. And if I restart, let's see how that looks. It's still not quite far enough. Let's increase that to like 4 and see what happens. There you go. That's probably too long, so I went too far. And I'm going to uncheck this use locality grid. I'm not entirely sure how that works, but if you fiddle with that, you'll often get different effects. So I want something kind of like that, right? You get these cool sort of constellations going on, maybe a little bit more. And I'll do 1 line per particle, so it's a lot less. And you'll notice they kind of like flicker on and off. They're not, the line connections themselves aren't living for very long. So one thing I like to do is you can increase this line connection lifetime. Let's do 10. And so they should start flickering a lot less. So basically each line will live for much longer than it used to, and we can try increasing this further. It stops having an effect the more you increase it. But you know, maybe if I don't want so many line connections, I'll also decrease this particle use amount. So only some particles will get a connection. There you go. So kind of you get this nice ambient effect now. And you can see how much complexity that added to our scene. That adds to just the shapes that we've made to really bring it to the next level. If I toggle this on and off, you'll see it's a subtle difference, but you know, your eye notices it and it does add up. And as you rotate and orbit around this, these dust particles really help give you a sense of perspective and parallax. I think the last touch I had was just adding a bit of text in the middle that said accept. So I'll add that again. This time instead of accept, I'll just write done. And it's way too big right now. So let's first justify its center. And let's make this a lot smaller with the size scale parameter here. I also don't want them to extrude really, so I'll just turn that off. You can see it says done. Let's rotate it so that it lays flat. It's a -90. And where'd it go? Oh, oops, sorry, not negative, +90. And you'll notice that it's offset. That's just how text is. So I'll just drag it into the center here. And there we have it. Done. I think in my scene I had a little camera that was just kind of doing this motion. I'll let you add that on your own. What I like to do at the end too is just fiddle with our glow and make sure that we have it just the way that we want it. And I also always tend to like add a sort of film grading effect. And I usually turn the chromatic and the blur down because it's just too much. And I'll just add a bit of noise. I think adding a slight bit of noise helps give it that sort of HUD graphics digital effect that's not too perfect, but feels like it could actually be on a screen or something. So just little touches. You can obviously play with a lot more post effects to get it just the way that you want it to look. And so right there, I think we've made a pretty cool result. So that's it. Thanks for watching. I look forward to seeing some really cool HUD graphics from all of you Notch users out there. And until next time, see you all soon.